Welcome, ladies and gentlemen. What I'd like to do is show you how to multiply binomials times binomials. And we're dealing with binomials when the power is equal to 1. So therefore, you can see each one of these, we have a binomial raised to the first power. Now, a couple things we need to remember is basically the property we're going to be following is the distributive property. So if I have a number of variable times the times an expression inside parentheses, we need to make sure by a distributive property that we're going to multiply the a times the b. And then, since a is positive, plus a times c, which is the other value. Okay? But you can see here what we have is we don't have just one number outside. We have two. So what that means is I'm going to have to apply distributive property with the first term as well as distributive property with the second term. So there's a lot of different ways that we can look at this. And I'm going to kind of go through 3 different ways of doing this, and therefore then then also as well as some shortcuts. So the first thing is looking here. This is a binomial squared, and I wrote this in there because I really want to make sure that you do not confuse this with x squared plus 1 squared. And that's a very common misconception from a lot of students. X plus 1 squared basically means x plus 1 times x plus 1. All right, so again, we have to go ahead and apply the distributive property. Now, the first way I'm going to do this is, again, just by using the distributive property. I'm going to take my first term in my first expression and multiply it by the first term and second expression, and then multiply it by the second term. So we have x times x, which is x squared. X times 1 is going to be a positive x. Then what I'm going to do is I'm going to take the second term in the expression and multiply it by both of the terms as well. Okay? So therefore I have 1 times x, which is again positive x, and 1 times 1, which is positive 1. Now you can see I have like terms. They both have x, and they're both to the power of 1, so I can combine them. So x plus x is going to be 2x. All right. You know what? Let's change this. OK. I'm going to come back to that one. All right. So then again, there's another way that we could look at this. Here's a kind of easy way, and it's a default way. A lot of people always remember FOIL. And FOIL, FOIL, FOIL. It gets said all the time, and people just remember it. So basically what FOIL represents is first, outer, inner, and last. So basically what that means is they want you to multiply the first 2 terms in each expression, which again we did over here. So that's going to be x times x. Then they want you to multiply the outer terms, which is going to be the last two, the outer terms on the outside. So that's going to be x times 5, which is x times 5. Then they want you to multiply the inner terms, which would be negative 3 times x. And then the last terms, which would be negative 3 times 5. And sometimes people, the way that I kind of drew it was like the FOIL face. You might be familiar with that. Negative 3 times 5 is a negative 15. Then what we go ahead and do is go ahead and write everything out and combine like terms. We notice that so therefore this is x squared, positive 5x, negative 3x, and then minus 15. You can write that out if you want to, if you don't already see the like terms. Okay, but again, we see that these both have an x raised to the power of 1, so we can combine them. So our final answer is x squared plus 2x minus 15. All right, and then the last method, what we like to do is thinking about area. And if you look at the area of a rectangle, a lot of times most people remember area equals length times width. So if you're multiplying basically 2 numbers, what you're really doing is finding an area. Now these are 2 binomials, and they have a variable in them. So visualizing what area they represent might not be as uncommon. But if you just think about this can equal an area, you have a length and you have a width. So what we're going to do is we're going to create a rectangle. All right, and we're going to put 1, we'll say here's the length and here's the width. So you put one expression, actually let's forget the boxes. We'll put one expression, x plus 5, on one side, and then the other expression, x minus 5, on the other side. Well, since we have 2 terms, I'm going to kind of segment them of the square, and then basically what I'm going to do is I'm just going to find the area of each box. So I have length times width, so x times x is x squared. X times negative 5, so that's going to be your height and base or length and width, which is negative 5x. X times 5 gives you the area of this box, which is positive 5x. And then 5 times negative 5 gives you the area of this box, which is negative 25. Now, you could write this out again. X squared plus 5x minus 5x minus 25. You can also notice, as long as you have your side lengths in descending power order, that if you have like terms, they're going to be going on the diagonal. So 5x minus 5x is obviously going to give you 0x. So my final product is going to be x squared minus 25. Okay? Now, we did 2 examples because I really wanted you to kind of understand. Here, this represents a binomial squared, and what this does is creates a perfect square trinomial. And this is what we call a difference of 2 squares, which creates, again, a binomial where the middle terms add to 0. And that's really, really important because when I'm looking at this, I notice that whenever you have the first term times the first, since you have the same term duplicate, what you know is all you need to do is square the first 2 terms. So it's basically 2x squared plus double the product of the first and the last term. So it's going to be 2 times 3 times 2x, and then plus the last term squared. So if you want to multiply this out, please do. Multiply it out using one of these 3 methods. But what you'll notice is you're going to get the exact same answer that I'm going to get, 4x squared, 6 plus 12x plus 9. So just a little shortcut. And again, we can only do that when we're multiplying 2 binomials that are exactly the same. Because what happens is you can multiply them out using the long way, perfectly fine, but a shortcut is noticing a binomial square is going to provide you with a perfect square trinomial. Square the first 2 terms, square the first term, square the last term, and then double the product of your middle terms. And that will always give you the correct answer. In this case, you can see this is not a binomial squared, nor is it a difference of 2 squares. So therefore, we're just going to have to multiply this the old-fashioned way. And again, I'll kind of do the box method again to kind of make sense here. Again, you're going to have 2 terms. So I'll do 3x minus 4 on one side, and then x minus 1 on the other. Again, you're just finding length and width of each box. So here I have 3x squared minus 4x minus 3x plus 4. Again, terms in the middle combine. So my final answer is 3x squared minus 7x plus 4. Okay, and the last example, again, is another shortcut. Notice that when I have the exact same terms, but one's positive, one's negative, my middle terms divide out, or subtract to 1, or subtract to 0, I'm sorry. So therefore, if I notice I have the exact same terms, the only difference is the sign, then all I need to do is square the first term, square the last term, and then subtract them. So in this case, I'll have 2x squared minus 1 squared. Well, 2x squared is going to be 4x squared minus 1. And there's my product. Please go ahead. Feel free to check my answer by using the box method, FOIL, distributive property, whatever you like to, and you'll see that you're going to get the exact same answer. So there you go, ladies and gentlemen. That is how you multiply linear binomials times linear binomials. Thanks.